8 minutes is to take you through how Concorde's nose droop worked on a flight to New York. So imagine we're at Heathrow, ready to go to New York. The pilots will first put on the navigation lights and the anti-collision lights. You can see them flashing where the wing joins the fuselage, the anti-collision lights, and if you can see wingtips, you can see the navigation lights. Now they're now ready to start engines and push back. The problem with Concorde is because of the design, when it's in its aerodynamic supersonic form, you can't see where you're going on the ground. So the first thing they do is lower the visor. So you can now see the actual cockpit window, but even like that you can't see the edge of the taxiway. So to taxi out onto the runway and to take off, they lower the nose to 5 degrees. So off it goes down the runway, faster takeoff than any other plane. It's got what's called reheat, so you see flames coming out the back of it. They turn that off when they get about a minute out of the airport before they fly over the Windsor Castle area, and then it heads out towards the Bristol Channel, keeping just under the speed of sound. When it gets out over open water, it's allowed to fly supersonic, so the first thing is the nose comes back up to the 0 position. And then the visor goes up. The visor is also a heat shield. The plane's going to go very fast and it generates a lot of heat. This one was the experimental Concorde for 5 years before the airline ones entered service, and it's also the fastest Concorde, 1,450 miles an hour. So it would get you from here to Manchester in about 2 and a bit minutes. But as it goes fast, the nose heats up. When they ran this one very fast, the nose got to 135 degrees Celsius, which the scientists decided was too hot, the metal would degrade. So the airline ones run at 1,350 miles an hour, 100 miles an hour slower, and that gets the temperature to 125, which is just about standable. So off it goes across the Atlantic, about 60,000 feet, almost twice as high as the planes it's passing below, is going at least twice as fast as them. As it approaches the coast, it has to slow down again, so the first thing they do is drop the visor again. And then the nose goes down to 5 degrees. Now, because Concorde slow speeds flies with its, if you like, its head up in the air, you still can't see the runway to land at New York. So this is the plane that experimented with how far you needed to lower the nose. And it's the droopiest Concorde of all. Its nose goes down to 17.5 degrees. So like that, the test pilots could clearly see the runway to land safely, but when the British Airways and Air France pilots started flying it, they really wanted to see the nose. So the airline ones, the nose isn't so droopy. It's 12.5 degrees, which this one can show us now. So now we're coming into land. The pilots will put the taxi lights on, they're the lights on the side of the plane, and they'll also put the landing lights on. The landing lights are retracted into the fuselage, so you'll see them coming down, and they light up when they're fully on. We don't have the taxi lights on yet, folks. It's the switch on the end of the right hand, thank you. And so that's what Concorde looks like coming into land. She touches down faster than any other plane by about 50 or 60 miles an hour, and had carbon fibre brakes to enable her to stop quickly and safely. So now on the runway, ready to taxi in, so we're going to put the nose back up to 5 degrees, and on this one, because of the way it's constructed, we have to first go back down 17.5. And now up to the 5-degree taxiing position. And like that, she will taxi into the air bridge to the landing gate, and then once it's stopped, the pilots will put the plane into its supersonic profile, so the arriving passengers can see what she looks like. So up to 0 degrees. And then the heat shield visor goes back up. And then we'll turn off all the lights, please. And that's it, folks. That's a run through of Concorde's nose droop. There's lots of interesting